Gemini 3.6 Flash claims to be 10x faster than previous models, but measured data puts the real number at 1.84x. If you're routing millions of tokens a month and you built your cost model around that 10x claim, you built it on sand. Gemini 3.6 Flash launched July 21st, 2026, and I went through every number, artificial analysis, Google's official API docs, and community benchmarks will actually stand behind, testing its 5 boldest claims to see which ones hold up. I pulled from 6 sources and scored only where real evidence exists. The speed story is more complicated than Google wants you to think, and there's one number in this review that's genuinely impressive and verified, and one that could wreck your production latency, and you'll see both before the conditional verdict. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. Alright, so let's get into it. 5 claims, source data only, no guessing. And if a number doesn't have a real benchmark behind it, I'm going to tell you that straight up. So say you're routing 50 million tokens a day through a Flash tier model. At $1.50 per million input tokens, the pricing math matters a lot. And if the speed or quality claims don't hold, you're either overpaying per task or shipping slower than you planned. And that's the real decision on the table. Claim 1, 10x faster than previous Gemini models. That's the headline number. And 280 tokens per second is what artificial analysis actually measured. So if you've already scoped a pipeline around a 10x throughput jump, and that number is wrong, you're re-architecting on someone else's timeline. Okay, so when I looked at the actual numbers, a community benchmark put Gemini 3.6 Flash at 303.6 tokens per second versus 165.4 for Gemini 3.5 Flash, which is roughly 1.84x, not 10x. Artificial analysis independently hit 280 tukas and ranked it number 1 for output speed, so that part is real. But the TTFT came in at 14.74 seconds, which is genuinely high. Now, a 1.84x throughput jump is still a real improvement, and if you're doing bulk processing where you need tokens out fast and don't care how long the first one takes, that's actually useful. The gap between 1.84x and 10x is enormous, but the underlying speed win isn't nothing, and it kind of depends on whether your workload is latency sensitive or throughput sensitive. Verdict on claim 1. Falls short. The 10x number isn't even close to the ballpark, and 1.84x measured is a pretty wide miss on a headline claim. So the output speed ranking is real, but the 10x framing is not. 0 of 1 claims holding up so far. Claim 2, native video, audio, and image processing without conversion delays. You've probably heard that Gemini handles multimodal natively, and that conversion overhead is where pipelines fall apart. So if you're processing hundreds of video files and the conversion delay claim is wrong, your throughput numbers are off before you even start. What surprised me here is how little source data actually exists. Video, audio, and image support shows up across community guides, sure, but I went looking for a single published benchmark, measuring conversion delays or processing latency on any of those modalities, and came up empty. The specific no conversion delays claim is testable, and nobody has tested it publicly, which is the biggest gap between the marketing and the available evidence. Claim 2, unverifiable. No benchmark, no timing data, no independent test, and this one stays open until someone actually runs the numbers on conversion latency. Still 0 of 2 claims holding up. Claim 3 costs significantly less than GPT-4 and Claude 3 Opus per task. And $1.50 per million input tokens is the number Google published, so if you're picking a model on cost and that significantly cheaper claim isn't backed by a real per-task comparison, you could be optimizing for the wrong thing entirely. So here's what I found. Pricing is confirmed. $1.50 per million input tokens, $7.50 per million output tokens, and cached reads at 0.15 per million. I'm received with 2 sources backing that up. But a published per-task cost comparison against GPT-4 or Claude 3 Opus doesn't exist anywhere in the evidence I could find. The raw token price is real, and the significantly cheaper per-task framing is still just a claim. Claim 3, unverifiable. Pricing is transparent and confirmed, which is good, but without a real per-task comparison, the significantly less part can't be scored, and there's not a single sourced head-to-head cost number out there. Still 0 of 3 claims fully holding up. 2 claims left, and one of them is actually partially verified, which means the scorecard is about to change. The context window claim has real sourced data behind part of it, and the creative output claim has none. So stay with me. Claim 4, a 1 million token context window without performance degradation. And 1,000,000 tokens is the spec number. So if you're feeding in a full codebase or a year of documents and the model starts losing recall at 800k tokens, your whole use case falls apart, and you don't find out until you're already in production. So here's the split on this one. The 1 million token context window is confirmed by multiple independent sources, and it's consistent with the Gemini model family specs, so that part is real. But any degradation test near the 1M token limit, no recall accuracy test, no reasoning quality benchmark, nothing at scale, I just couldn't track down a published figure for any of it. The spec exists, and the behavior at scale is an open question. Claim 4, partially true. The window size is verified, the degradation-free part is not, and the scale performance doesn't have a single community test behind it that I could find, so the claim gets half credit, which moves us to 0, fully verified, and 3, partially true, out of 4 claims checked. Claim 5, creative outputs rival or exceed specialized tools in speed, and 280 tokens per second is the verified throughput number, but if you're replacing a specialized coding or writing tool with Gemini 3.6 Flash, and the quality claim is just marketing copy, you're going to feel that the first time a client asks why the output is off. I went looking for at least one community benchmark on code generation or writing quality and came up empty. No pass-fail rate, no scored comparison against a specialized coding tool, no writing quality evaluation anywhere, and raw throughput at 280 tokens is confirmed, but speed on a creative task depends on output length and quality, not just tokens per second, which makes this the weakest evidenced claim in the whole set. Claim 5, unverifiable. No benchmark, no comparison, no independent evaluation, and the final tally is 0 of 5 claims fully holding up with 4 partially true or unverifiable. The creative output claim needs hands-on testing before anyone should take it seriously in a production decision. Okay, so where does Gemini 3.6 Flash genuinely deliver? Output speed is real. Artificial analysis ranked it number 1 at 280 tokens, and that's a sourced, measured result. The 1M token context window is confirmed by multiple independent sources. Pricing is transparent at $1.50 input and $7.50 output per million tokens, corroborated by 2 sources, and the 1.84x speed uplift over Gemini 3.5 Flash is a real sourced improvement. And where does it fall short? The 10x speed claim overshoots by a wide margin because measured data says 1.84x, not 10x. TTFT at 14.74 seconds is genuinely high and will hurt any latency-sensitive application. Multimodal processing has 0 sourced benchmark data, and creative output quality versus specialized tools is completely unverified. No benchmark, no pass-fail rate, no independent evaluation found. So here's the honest take. I went in thinking at least 2 or 3 claims would come back cleanly verified, and 0 of 5 held up fully. But the speed story is real where it counts. 280 tokens, ranked number 1. Worth it if you need maximum throughput on bulk token workloads and can live with 4.74 seconds to first token, and skip it if you need low latency to first response, or if you want the multimodal and creative claims verified before you commit to production. Alright, so I ran Gemini 3.6 Flash against GPT-4o next, and the per task cost math flips in a pretty interesting way once you factor in output token volume. That full breakdown is on the channel if you want to see where the pricing story actually lands with real task comparisons.